Hello, Chemistry 10 and Chemistry 10H students. This is one of two videos on temperature conversions. This will be between Kelvin and Celsius and Kelvin. These are just the notes from class, so just as a little bit of a recap, temperature is a measure of the average kinetic energy in a sample. All that means is that the higher the temperature, the higher the average speed. I just say average because within a sample, there's always a lot of variation. So within temperature, we've got three main units: Fahrenheit, Celsius, and Kelvin. Kelvin is useful because of the fact that it cannot be negative, which means that when some of you take physics in future years, you'll actually be doing calculations that involve Kelvin, and those calculations only work because Kelvin cannot be negative. Both Fahrenheit and Celsius can be negative. For that reason and other reasons as well, Kelvin is not a degree, so it's just K as the unit, uppercase K, whereas with Fahrenheit and Celsius, it is degrees Fahrenheit, degrees Celsius. And then another useful factor of Kelvin, 0 Kelvin is absolute zero, which is the temperature at which particles stop moving, an extremely low temperature that will never be achieved. It's around negative 459.4 degrees Fahrenheit. I forget what it is in Celsius. I would have to calculate it. All right, let's work through some problems. This is the base formula that we're going to be using for both of these types of unit conversions. Now let's take a look at this first type of problem. So we have all of these are in degrees Celsius, which means we plug them in for TC. So I get 330, and you could put a dot here. I'll probably have talked more about that in class. When we are converting between Celsius and Kelvin and Celsius, we round to whatever place that we start with. So because 57 was to the nearest ones place, that's where we round to. That is only applicable to the H class. So it's not number of sig figs, it's actually the place. So now I have one with negative 40. So when I first put in my calculator, I get 233 Kelvin, and those of you in the 10 class, so you could leave it as such. If we're going to be considering sig figs, this would be 230 Kelvin, just because that zero is not significant with degrees Celsius. I have probably told you in class if I'm going to be grading you on that or not. I don't always. And then I've got negative 40 with a dot this time. So those of you in the 10 class, you'll already have done this. It's 233 Kelvin. And then for those of you in the H class, this should be 233 Kelvin. So anytime that you are starting with Celsius, you're just adding 273. Right. Now I've got another example just with the opposite of this. There's a couple ways you could do it. You could just memorize that you're going to subtract 273. That's fine. You could take this equation here and then just use some algebra to rearrange it. So subtract 273 on both sides. I get that TC is equal to TK minus 273. Or I'm going to do it the way that probably most of you would prefer, is you just take the example and plug in for what you have. So my first one, I've got 200 Kelvin, so I plug that in for TK, and then I solve for TC. I'm going to just round it to the ones place. We got negative 73 degrees Celsius, so that is extremely cold. Now I have 251. So we get negative 22 degrees Celsius, so also cold, though not as cold as the last one. Now I have 40 Kelvin, so I can already tell that's going to be extremely cold. So I got negative 233 degrees Celsius. That is all for this video. I really appreciate you taking the time to watch this. Have a wonderful evening.